Hey Pamela, we really let the launches get away from us covering JWST yesterday.
Yeah, we did. How many are there?
5, and 3 of them launched yesterday.
Well, I guess that's not so bad.
But SpaceX's Booster 7 had an oopsie.
Okay, but at least there's some good news from history.
Yes, this week in rocket history, I have a Japanese mission that is studying the magnetosphere, and a special treat for the end of the season.
Well, I guess I'll just have to watch the end of the episode to find out what that treat is. All of this and more, right here on the Daily Space. I am your host, Dr. Pamela Gay.
I am your host, Eric Mattis.
And we're here to put science in your brain.
To get it out of the way at the top, the 50th Starlink mission launched on a Falcon 9 from Vandenberg Space Force Base on July 11th at 1:39 UTC. The mission launched 46 satellites into a new 97-degree shell of the constellation. The booster landing was successful. In other SpaceX news, Booster 7 suffered some sort of explosion during testing of its Raptor 2 engines. During a test on July 11th, the engines all started flowing oxygen now, which has been observed before as part of a startup test. After a couple of seconds of oxygen flow, the white vapor turned into flames and debris went flying. Video shot by observers miles away recorded a loud bang. These videos were posted to Twitter, and SpaceX's CEO Elon Musk commented in a now deleted tweet that it was, quote, just booster testing. 2 hours later, he admitted that it was, quote, actually not good. He further commented that there was a risk of fuel-air explosion with liquid propellants. As of recording this episode, no reason for the anomaly has been revealed.
We missed it happening this weekend, but Russia launched their latest Glasnost K navigation satellite using a Soyuz 2.1B frigate rocket on July 7th. The launch was successful. In the first of 2 launches on July 13th at 0600 UTC, Rocket Lab launched the NROL-162 mission from LC-1A at their launch site at the Mahia Peninsula in New Zealand. The launch was successful, inserting an unspecified number of classified satellites into orbit. No recovery attempt was conducted. Rocket Lab continued their tradition of delightful mission names, giving this one Wise One Looks Ahead. This mission is the first of 2 NRO launches that Rocket Lab will launch in a short period of time. After this launch, NRL 199, nicknamed Antipodean Adventure, is scheduled to go up no earlier than July 22nd from the other pad at Rocket Lab's launch site, LC-1B. In related news, Rocket Lab is still in communication with its Lunar Photon Space Tug after almost 700,000 kilometers from Earth. It performed one further burn of its Hyper-Curie engine after separating Capstone and is now off doing a mission of its own. Rounding the last bend with this clown car race of launch coverage. On July 12th at 1630 UTC, a Long March 3B launched the third Tianling-2 relay satellite into geostationary transfer orbit from the Xichang Satellite Launch Center in China. Once in geostationary orbit, the satellite will be used to send and receive data from various satellites and even China's space station. Tianling-2 will also relay telemetry from rockets as they head to orbit.
Finally, to wrap up the rocket news for today, Arianespace successfully conducted the inaugural launch of the Vega C rocket from French Guiana. This is the first launch of a new rocket out of several expected this year, including SpaceX's Starship Super Heavy and United Launch Alliance's Vulcan. Vega C isn't that radical of a design for a new rocket, as designs go. What is new is the first, second, and fourth stages. The first stage is the P-120C, a slightly bigger version of the P-80 flown on the current Vega. The P-120C will be used as side boosters on the Ariane 6 rocket. The second stage is also slightly bigger than the one on Vega, with 40 tons of propellant compared to the 23 tons on Vega. The third stage of Vega C is the same. The fourth stage of Vega C is called the Avum Plus because it has more fuel than the one on Vega. The biggest difference on Vega C is its payload fairing, which is about twice as big in volume compared to Vega, allowing Vega C to launch bigger single satellites or lots of small to medium satellites to different orbits. Because this is a new rocket, and despite the seemingly modest upgrades, Vega C carries a traditional new rocket payload called LARIS-2. LARIS-2 is basically a big nickel ball covered in retroreflectors that will be used to measure a property of general relativity called frame dragging. Lasers on the ground will fire on the satellite, and instruments will then measure how long the light took to return. LARIS-2 also carried 6 CubeSats, which will conduct different science experiments. The launch occurred at 1313 UTC and was successful. Side note, the first LARIS satellite was launched in 2012 on the first launch of the original Vega. Coming up, we switch from all of these rockets to some planetary science. Stay tuned.
Research papers on Bennu have been coming out in droves these days as scientists analyze all the data collected by the OSIRIS-REx mission. And we have not only one, but 2 new papers today. First up, in a new paper published in the journal Science Advances, a team of scientists characterized the layer of rock just below Bennu's surface. They found that this layer is, as expected, loosely bound rock bits. They also found that this layer contains twice the void space as the overall asteroid. Lead author Kevin Walsh explains, quote, "The low gravity of rubble pile asteroids such as Bennu weakens its near subsurface, but by not compressing the upper layers, minimizing the influence of particle cohesion. We conclude that a low-density, weakly bound subsurface layer should be a global property of Bennu, not just localized to the contact point." End quote. Many of our community will recall that the touch-and-go portion of the mission did more than just boop our rocky little asteroid. The sampling arm actually plunged about half a meter into the asteroid itself, basically because of all of those loose rock and void spaces. Not only that, but images taken by an onboard camera revealed the displacement of a 40-centimeter rock. Oh, and that sample collection left behind a 9-meter-long elliptical crater. More on that research can be found in a companion paper published in the journal Science. We'll have links to both papers in our show notes at dailyspace.org. The rubble pile nature of asteroids like Bennu and Hayabusa 2 target Ryugu presented scientists with a new mystery to solve. Before the arrival of these 2 missions at their targets, astronomers expected to see a relatively smooth and dusty surface, sort of like our moon. Instead, they found tons and tons of small rocks and boulders and dust. So many rocks and boulders. But that dust was intriguing. And it turns out that rubble pile asteroids are not static in shape, but they are static when it comes to dust. In a new study published in Nature Astronomy, scientists detail the calculations and modeling done to understand the nature of dust in space, particularly at these rubble pile asteroids. First off is the action called electrostatic lofting. Co-lead author Kai Wang explains, quote, "As the sun's rays bathe patches of porous regolith, negative charges start to build up on small grains of dust. Those charges will accumulate until suddenly the particles burst apart like 2 magnets repelling each other." End quote. And these grains of dust can fly away at more than 8 meters per second. But from the models, this mechanism only works on smaller asteroids where these grains of dust can actually be lost to space. That loss causes more erosion as more of the surface is exposed to stellar winds and sunlight. until eventually the asteroid will be clean of dust but be covered in, well, rocks and rocks and rocks and boulders and rocks. Oh, and this strange electrostatic scrubbing effect could cause changes in the asteroid's orbit as well. And we'll know more about how that could work after the double asteroid redirection test does more than boop a tiny asteroid moonlet. Now let's get away from Bennu. Will we ever really get away from Bennu around here? Anyways, and talk about the first exoplanet discoveries. It has been 30 years since the first exoplanets were detected. Just as Beth and I was working at an observatory and she was also, we were both seniors in high school. Back then, scientists announced the discovery of at least 3 rocky planets orbiting a pulsar cataloged as PSR B 1257 plus 12. In the years since that wild discovery, only a handful of pulsars have been found that host exoplanets. And these pulsars do not seem like good places to have planets anyways. The violent conditions that go along with pulsars, including jets of high-energy particles getting released like railguns at regular intervals, have led to exotic planets, including one made of diamond. Still, despite the low rate of detection, that hasn't stopped scientists from looking, and now a group of astronomers have conducted the largest search yet for exoplanets orbiting pulsars. The results were presented at the National Academy meeting earlier this week. Per the press release, quote, "The team looked for signals that indicate the presence of planetary companions with masses up to 100 times that of the Earth and orbital time periods between 20 days and 17 years." End quote. And they found 10 potential detections. The most promising are 2 possible planets orbiting pulsar PSR J 2007 plus 3120, which has potential orbits of 1.9 and 3.6 years. And while the research didn't find evidence of any particular bias for planet mass or orbital period, many of the planets have highly elliptical orbits. That result indicates that the formation process may be very different from traditional star systems like our own. It's kind of amazing that we haven't really researched these strange planets in all this time, but we're excited to see where this research leads. And now we return to the land of rockets as Erica's back in time for our weekly rocket history segment. Stay tuned.
It's the last rocket history of the season, and we're ending on a good note with Japan's GEOTAIL mission. This satellite was a collaboration between the Institute of Space and Astronautical Science of Japan, the predecessor of the Japan Aerospace Exploration Agency, JAXA, and NASA. Prior to the founding of JAXA in 2003, ISAS worked on satellites. The National Space Development Agency of Japan, NASA, worked on rockets and human spaceflight, and the National Aeronautical Laboratory was responsible for flight research. GEOTAIL's mission was to study the Earth's magnetic field in the area opposite the Sun, called the magnetotail. The magnetotail is the most active part of the magnetosphere because it interacts with the solar wind, which stretches the tail out. GEOTAIL was primarily an ISAS mission. NASA's major contribution to the project was the Delta II launch vehicle. NASA also provided several of the spacecraft's instruments. An interesting connection between the Delta rocket and the Japanese space program is that Japan's first large orbital rocket after its early converted sounding rockets was a license-built Delta first stage and boosters with a Japanese-built second stage engine. Over time, the rocket evolved into versions with more and more Japanese components, starting with a liquid hydrogen, liquid oxygen second stage. To properly measure the magnetotail, the satellite was launched into an orbit so high that the easiest way of describing it is in terms of Earth radii instead of kilometers. The intended orbit was between 10 Earth radii at perigee and 220 Earth radii at apogee. To get there, the Delta sent GEOTAIL into a lunar flyby trajectory, stealing some momentum from the Moon to fling the satellite into a higher orbit, just like Challenge Portal. The first lunar flyby set up the trajectory for a second, pushing the apogee even further out. GEOTAIL has accomplished a lot since it was launched on July 24th, 1992. GEOTAIL flew by the Moon extensively, 14 times between 1992 and 1994, to keep its orbit in the magnetotail as the Earth orbited around the Sun. The satellite is still operational today, with the current apogee of about 30 Earth radii. Speaking of the Moon, Earth's natural satellite was also used to fix the spacecraft. In 1993, one of GEOTAIL's instruments malfunctioned, and despite a lot of troubleshooting, the operations team couldn't resolve the problem. So, the mission controllers decided to reset the instrument, which involved deliberately flying the spacecraft into the Moon's shadow while disconnecting from battery power, in the hopes that this would force a reset. Happily, the fix worked, and the instrument started functioning again. Sometimes unplugging something and plugging it back in really is the solution. GEOTAIL continues to produce science 30 years after its launch. In 2016, GEOTAIL worked with NASA's Magnetic Multiscale mission to investigate magnetic reconnection, a process where the magnetic field lines from different sources break and attach to each other, causing bursts of energy. And, in 2018, GEOTAIL discovered special waves in the magnetic field called Kelvin-Helmholtz wave, which transport solar plasma and other energy to the magnetosphere. Besides GEOTAIL's mission to the magnetotail, the satellite has contributed to lunar science by measuring the Moon's weak atmosphere during all those flybys. Also this week in rocket history, Robert Goddard launched the fourth liquid-fueled rocket ever on July 17, 1929, from his Aunt Effie's farm in Auburn, Massachusetts. This happens to be 39 years, 364 days before the launch of Apollo 11 on July 16, 1969, which is a total coincidence, but it's quite nice given how significant both events were. The flight lasted just 18.5 seconds, which included sitting on the launch pad for 13 seconds before the rocket started to lift. It reached an apogee of 27 meters, traveling 52 meters downrange. On board the rocket was a small camera, a thermometer, and a barometer, all of which were recovered intact after the flight, making this the first instrumented rocket launch. Known as the Goddard 3 launch vehicle, the rocket was quite small by today's standards, measuring just 3.5 meters in length and 66 centimeters in diameter. It weighed about 14.5 kilograms and was fueled by 6.4 kilograms of gasoline and 5 kilograms of oxygen, for a total loaded weight of 25.9 kilograms. The flight was reportedly bright and noisy, which attracted a lot of attention and resulted in a lot of, quote, moon rocket publicity. Robert H. Goddard went on to develop increasingly sophisticated rockets before he passed away on August 10, 1945. His contributions to the field of spaceflight were largely unrecognized in the United States until the dawn of the space age. On May 1, 1959, NASA's Goddard Space Flight Center in Greenbelt, Maryland was established, and on September 16, 1969, the 86th Congress authorized the issuance of a gold medal in the honor of Professor Robert H. Goddard. And now for some statistics. The number of toilets in space is 8, 4 on the ISS, 1 on Soyuz MS-21, 1 on the Crew Dragon Freedom, 1 on Tianhe, and 1 on Shenzhou 14. We keep track of orbital launches by launch site, also called spaceport. Here's that breakdown. USA 40, China 22, Russia 6, New Zealand 5, Kazakhstan 4, French Guiana 2, India 2, Iran 1, South Korea 1. From those 82 launches, a total of 1,239 spacecraft have been put into orbit in 2022, with 861 of them being Starlinks, which is about 7 of every 10 satellites launched so far this year. There have also been 14 humans sent into orbit this year on board 4 launches. Finally, there have been 5 two-person EVAs conducted by 7 astronauts. Your random space fact for this week is that Robert Goddard's 4th liquid rocket launch from earlier in the show resulted in the local fire marshal banning future test flights from Aunt Effie's farm, so Goddard moved to New Mexico to continue his research. This has been The Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.